So if we're looking at ratio, the first thing we always learn to do as ratio is just to cancel a ratio down. And there are two sort of acceptable forms of ratio. If you're asked to just cancel a ratio down, so we might have something like this, 5 to 20, then we cancel it down like a fraction. We simplify it into the simplest form. So the simplest form of the ratio, well, there's a factor of 5 on this side, there's a factor of 5 on this side, so 1 to 4. Or if I've got something like, 21 to 28, there's a factor of 7 on this side, there's a factor of 7 on this side, so 3 to 4 if I divide by 7 and then divide by 7. So that's cancelling down, finding the simplest form of the ratio. That's the first thing you can be asked to do. The second thing you can be asked to do is you might have something like, well, let's take this example again, 21 to 28, and you might be asked to put the ratio in unitary form, or often it will say in the form 1 to n. So this is one of the first places where ratios and fractions look different. Fractions, you have to have a whole number on the top and a whole number on the bottom. With ratios, I can divide this side by 21, I can divide this side by 21, and I can end up with a whole number on one side and a fraction on the other. I'd probably be a bit more likely with ratios to write it as a decimal. So 1 to 1.3 recurring. That is a perfectly good ratio. I don't have to have a whole number on both sides. If the way they're asking you to write the ratio insists on having a 1 on one side, then the other side might just have to be a decimal. So I could have a 2 to 5, and the question could say, write that in the ratio n to 1. Okay, so the 1 doesn't have to be on the left-hand side. Usually it is, but the 1 could be on the right-hand side. In this case, I'm going to have to divide by 5 on this side to get the 1. I'm going to have to divide by 5 on this side. So 2 divided by 5 is 2/5, or 0.4. So in the form that we want, in this form here, 0.4 to 1. Now, those are the two ways of cancelling down ratios. The other thing that we learn as a sort of initial introduction to ratios is how ratios and fractions link to each other. So let's start again with a ratio 2 to 3, for example. This means I've got 2 things on this side for every 3 things on this side. Okay, now what the mistake a lot of people make is compare that to the fraction 2/3. But let me show you why that's not quite true. If I've got 2 objects over here, every time I've got 3 objects over here. Okay, so that means I could have 2 over here and 3 over here. I could have 4 over here and 6 over here. We're still in the ratio 2 to 3. For every 2 over here, there's 3 over here. I could have 6 over here for 9 over here. Okay, 6 to 9 would cancel down to the ratio 2 to 3. It's the same as the ratio 2 to 3 because for every 2 objects over here, I've got 3 objects over here. I'm comparing amounts. So if I've got the ratio 2 to 3, and let's say this is, I don't know, boys on this side to girls on this side. So I've got 2 boys to 3 girls. What fraction of this group of people is boys? Well, over here, I've got 2 boys out of 5, haven't I? 2 out of 5. For every 5 people, 2 of them are boys and 3 of them are girls. So the fraction is 2/5, means the ratio of boys to girls is 2 to 3. If 2/5 of the population is boys, that means 3/5 is girls. So the ratio of 2/5 to 3/5 is 2 to 3. So people often get ratios and fractions confused, and I think that's because when we cancel down ratios, we do the same technique as cancelling down fractions. But remember, a ratio is for comparing amounts, a fraction is for describing a proportion, right? So 2/5, or writing it as a division sum, or if you like, 2/5 would be a way of putting it on a number line 0 to 1. 2/5 would be 2/5 of the way along from 0 to 1. It's a slightly different thing than saying 2 boys compared to 3 girls. Okay, there's the 3 sort of introductory ideas with ratios.